Hey, what's up, everybody? Welcome back to another live stream from Adafruit. Today, we're celebrating CircuitPython Day.
Yay!
Yeah, we have here with us is Dan H., who is core lead on CircuitPython Dev. So we're going to take about an hour to do a live stream, and we are hanging out in the Discord chat room. So if folks want to join in and say what's up, maybe ask some questions, you can do so by hitting up the Discord link, which is ada.fru.it/Discord. Dan, hello. Good morning.
Happy CircuitPython Day.
Yes, happy CircuitPython
Yeah,
Day.
this is great. So we picked a date. Actually, any numbers can look like snakes, but 9/9 looks like snakes. And 9/9 is easy to remember, and it was on a Wednesday, which is Adafruit Big Video Day. So that's good too.
Yeah.
So I just want to say we're dedicating CircuitPython Day this year to the Lambda Labs Beirut hackerspace in Beirut, Lebanon. And as you know, there was a huge explosion in Beirut in a warehouse on August 4th, which is not so long ago. And many people were killed and injured, and thousands of people left homeless or had their homes destroyed. So in the aftermath of that, Lambda Labs Makerspace stepped up and joined the efforts to rebuild their community, doing search and rescue, restoring damaged homes, and volunteering, providing aid tents for food, shelter, and helping construction engineers with the rebuilding process. Last year, Lambda Labs Makerspace in Beirut was a partner for CircuitPython Day, and this year we're dedicating it to Lambda Labs for all the amazing work they're doing in the Beirut community to help recover from this explosion. And if you'd like to help, you can donate to some fundraisers. There are links in the live broadcast chat in Discord that you can look at, and either of those is fine. Just click on the links and find out. And you'll be hearing more about that later. Okay.
Excellent. Thank you.
And I've posted the links to all the blog posts. It has all the resources if you guys want to donate to the cause. Definitely worth checking out.
Excellent. We also have a link down here in the bottom of the video.
Yeah.
Excellent.
Great.
Cool. There's some other things we want to do, sort of housekeeping in the morning. We have some awesome promotions going on as well. If you go to adafruit.com/free, you can see all the new things that were added, mostly stemma boards.
Yeah. So we're celebrating over 50 boards. And with that, when you get an order that's over, I think it's $150, you will get a random assortment of 15 different stemma boards. If you log in with your Adafruit account, we'll keep track of those. So you'll get a different one each order while supplies last. So definitely check that out. This week's 3D printing project has a lot to do with stemma. It's a bunch of Lego compatible bricks to fit all of the different size of stemma boards that we have. So we'll go over that. We'll post some links over it, and we'll do a nice little recap next week. But definitely check out adafruit.com/free to see all of the deals. There's a bunch on there. We still have the free CPX, the promo proto boards, and free shipping. Different tiers for all of the prices, all listed there.
Yep. Just another kind of a Adafruit is open safely. Check out adafruit.com/open safely to see all of the different procedures Adafruit is taking and precautions to make sure that your orders are, well, good.
So we're hanging out in the Discord. Go in there and say hello.
That's, yeah, there it is. There's the link again if you'd like to join us. It's adafru.it/Discord.
I like using discord.gg/Adafruit. That works as well.
Sure, whichever you like.
All right, let's go ahead and continue with the stream. Okay. Dan, this morning you're going to show how to set up a project.
How to set up a board, and we'll write some fun code.
Can you hear us?
Okay.
All right, so I'm all set. So let's now, I'm Dan Halbert, and I am one of the people working on CircuitPython for Adafruit. I'm paid by Adafruit to do that. And I work primarily on the actual implementation of CircuitPython. That is the core firmware for that. A few libraries, but mostly the core firmware. And I've been doing this for just about a little more than 3 years now. and been having a great time doing that. I'm remote, like many of Adafruit's engineers. I don't live in New York City, but I'm in touch with everybody all the time at Adafruit. So let's go on. Let's go ahead and talk about what is CircuitPython. Okay, so you've heard it, and maybe the people who are watching this right now are mostly bringers, but we hope to record this and make it available to other people who want a more beginner's introduction. So Python, let's first talk about what Python is. Python, it's an easy to learn programming language, and it's suitable for beginners. You can also use it, professional programmers use it all the time, but it was originally cast as something that was really easy to use and easy to read and easy to write. And unlike, say, C, it's got a bunch of high-level data types that are built in. So it's got strings built in. It's got long integers, like arbitrary precision integers, not just ones that'll fit in 16 or 32 or 8 bits. It's got dictionaries. So you can look up, you can give a key of something that's any object and get a value back. It's got sets. It's got a bunch of stuff like that. And also, really importantly, it does memory management by itself. So you don't have to clean up after yourself. You don't have to allocate storage explicitly. It handles all that in the background. So what about CircuitPython? So originally, let's talk about something called MicroPython. A fellow named Damien George, who's in Australia, he's a physicist. About 7 years ago now, I think, he decided that he wanted to make a version of Python that could run on microcontrollers. Microcontrollers are very small, tiny computers that you might find in your toaster oven or your dashboard. What's in your phone is more sophisticated than microcontrollers. Any object in your house that now you've got dozens of them that does things that are slightly intelligent, your thermostat, your webcams, whatever, they all have microcontrollers in them. And so he couldn't start with regular Python, the regular Python implementation, which is called CPython, because it's written in C. So Damien started a complete reimplementation of Python, called it MicroPython, and he emphasized low memory use because there isn't a lot of memory available on microcontrollers. There's some flash and some RAM, and often not that much of each. So as you know, regular Python, it says like it comes batteries included, which means that when you download it and install it, it comes with a lot of libraries already built in. There isn't room for that in MicroPython or CircuitPython, but instead of that, we've added additional functionality for physical computing, and I'll talk about what that means in a bit. So what happened? How did CircuitPython come about? Well, we started trying out MicroPython and thought it was great. We got it to run an ESP8266, connected it up to our breakout boards and things like that. And then we realized after a while that the way it was really, MicroPython is really oriented toward professional programmers, not so much the beginning programmer. And so the goals that we had were different, but we wanted to be able to use MicroPython as a starting thing, and it was a great piece of software. So we did fork it on GitHub. All these things are open source, both CircuitPython and MicroPython. But it's a friendly fork. We have different goals, but we're in constant touch with the MicroPython people. We take things from them. They take a few things from us, and we talk all the time. Also importantly, we want to implement CircuitPython in a variety of different microcontrollers made by different manufacturers, and they have different hardware on them. But we wanted the interface to be the same across all of them. So that was something that MicroPython wasn't emphasizing at the time. They had specialized I/O libraries for each different microcontroller, and we said we'd rather have something uniform. So let's talk about physical computing. That's a buzz phrase I used. What I mean by that is using computers, or in this case microcontrollers, to control things or to get information from things that are like some kind of electrical signal, digital signals or analog signals. Your desktop computer does this to a limited extent, but you can't kind of connect arbitrary LEDs or motors to it or anything like that directly. But you can do that with microcontrollers. So we're talking about like motors, servos, and solenoids, buttons, switches, knobs, and dials, LEDs, red, green, blue LEDs, RGB LEDs like our NeoPixels and dot stars, tiny displays of various kinds, sounds, and then all kinds of sensors. There are all kinds of sensors that you can talk to based on some kind of communications protocols that most people don't know about. Like they're called I2C or SPI. Most people who aren't familiar with microcontrollers don't know those, but we support them. So then the question is, well, what kind of boards run CircuitPython? So I have a bunch of boards here. Let me switch to my overhead camera here. See if I can get this a little closer. There we go. And I'll turn on the light. So all kinds of microcontroller development boards run CircuitPython. If you're not familiar with CircuitPython, you probably know about Arduino nevertheless. And the microcontroller that's on Arduino and on a classic Arduino board is not powerful enough to run MicroPython or CircuitPython. It just doesn't have enough memory, either flash or RAM. But there are plenty of boards that are newer than that, because the original Arduino board is like 15 years old at this point. And there are much better microcontrollers that are available that cost the same. You know, all these microcontrollers only cost like between 50 cents and $4 or something like that. So here, for instance, we've got an Arduino shaped board. This is that we sell. It's called the Metro M4. It's the same shape as an Arduino. It also runs Arduino software, but it runs MicroPython. I've got it connected up to some sensors here, a light sensor and a humidity sensor, and also a servo. You've got a line of boards called feathers, all of which are the same shape and have the same pinout, and they have a bunch of different microcontrollers on them. SAMD21s, SAMD51s, STMs, NRF, which have Bluetooth support, and eventually Wi-Fi, ESP32s. And you can put things on top of these. We have a bunch of things called feather wings that fit on top of the feathers or fit on these things called doublers or triplers. But these boards have the same pinout, and you can put one on top of the other. So if I take this out, I can stack these things up, for instance. So here I put a bunch of NeoPixels on top of a microcontroller board. And then we've got some educational boards. And this is here's our typical one. It's called a Circuit Playground Express. And we've also got Circuit Playground Bluefruits, which are more sophisticated and can do Bluetooth. And they're blue, like this one. So let's talk about, let's say you want to get started with this and you buy one of these Circuit Playground Express boards from us. Okay, so maybe I'll put myself in the corner here. No, Pedro, I'm going to start sharing the screen. So let's see what I can do here. I've got a lot of windows open here, so let me just put this down, and I'll share this screen over here. And let's open a browser. There we go. I got to put it on the other side. Okay, so suppose you buy one of these boards, and let's go back to okay. First, it comes. Sometimes some of the boards come with CircuitPython on them. Some of them don't. Some of them come with some Arduino demo or something like that. So usually, what you want to do is get the latest version of CircuitPython, download it, and put it on the board. So if you open a browser and you go to CircuitPython.org, And let's make this, and then I can make this bigger. There we go. If you go to circuitpython.org and then click on downloads, you'll see a bunch of boards. And you can type in, for instance, I have a playground. You can start typing something, and it'll narrow that down to everything that just has the word playground in it. Here's a circuit parameter express right here. That's what I've got. So let's go here. And now here's the board that I bought. And I could choose a development version or the latest stable version. Let's pick the latest stable version. So I can just click download. And it goes down to here. It's in my download. It'll be in my download folder. And I'm using Windows here just to make it, because a lot of people use Windows. And but you could do this on Mac or Linux also. So let's go ahead and plug this board in. Okay, let me find my loose cable. Okay. Oh, it says there's, it's complaining a bit. I've actually already, let's see. Now, normally when you plug this in, if it came straight from the factory, it won't have CircuitPython on it. And so what you want to do is get it into, start the bootloader that's on the board. The bootloader is in the flash RAM on the board, and it lets you load various different programs. CircuitPython is just another program. It could be like the Blink program in Arduino. CircuitPython is another program that you can use. So to get it into bootloader mode, find the reset button on the board and just double click it. And then over here, you can see, I'm not sure if I can make this bigger. Nope, sorry, unfortunately. But it says CPlay boot right here. And that means that's the boot drive. It's actually not really a drive. It looks like a USB drive, but it's kind of a fake. The software is pretending to be a drive. And whatever you drop on that is a program that it's going to store in flash memory on the board. So I did download Circuit Playground, the version of the latest stable version of CircuitPython. And it's a UF2 file. That's a special kind of file. It stands for USB flashing format. It's in a format that was invented by Microsoft, and they developed this UF2 bootloader, which is really easy to use because it presents as a drive. You don't need to use a separate program to load things onto the board, which is really convenient. So what we'll do is we've downloaded this thing, and we'll just drag it on to the CPlay boot drive. And then it thinks for a little while, and then it comes back. And now notice it says CircuitPy. It doesn't say CPlay boot anymore. So what's happened is we loaded CircuitPython onto the board. The bootloader's still there. We didn't replace the bootloader, and we could get it back again by double clicking. But now CircuitPython is running, and it shows us a drive, and it's presenting a real USB drive called CircuitPy. It's like, for boards like the Circuit Playground Express, it's about 2 megabytes, which is a tiny, tiny USB drive, but it's plenty of space to store your programs, to store libraries, and to store data like pictures and sounds. So we've got that running now. So now how do we talk to the board? Well, one way to talk to the board would just be to put things into the CircuitPy drive. And another way would be to, you can talk to it over what's called the REPL, or the read eval print loop. If you installed regular Python, you could start it, and then you could type things at it and ask and just interact with it. You don't have to use it to run a program. So let me start an editor called Mu. But first, I'll show you where to get that, actually. If you go to codewith.mu, this website, this is a great editor developed by Nicholas Tollervey in the UK. And he designed it to be used by beginning Python programmers, not necessarily CircuitPython, but regular Python and CircuitPython and other things too. So this website lets you download this open source piece of software. Just go to it, click on the download link, and pick your operating system. So in the case of Windows, click 32-bit or 64-bit, probably 64-bit. You can follow the instructions if you want. Installing it on Linux is a little bit different, but you can read all about that at this website. So I've already downloaded and installed this, so we don't have to wait for it. But here's what it looks like when you start it. And let's, now it's talking to, if you click on, when you first plug in your board, you'll see that you're in CircuitPython mode, okay? Because it detects that there's a board that's plugged in already. So let's go ahead now and let's make this a little bit bigger. And let's click this box that's called serial. This lets you talk. This is you type at the read eval print loop that CircuitPython presents. Okay. So here I'm talking to the board here, and if I just type, hit the enter key, you can see this prompt, greater. Let's make that even bigger. There we go. That should be easier to read. So what can we do with this read eval print loop? Well, you can just type stuff. You can type 2 + 2, and in fact it is 4. That's good. You can type Python statements like, here's a print statement. Let's print hello world. It does that. Okay. And there's a bunch of stuff, other stuff that you can do, and you can try out all kinds of Python things here. But suppose we want to do something a little more interesting here. There's on this board, let me point to it. There's a red LED right here. And it's connected to pin D13 for digital, D for digital. And we can turn that on and off. How do we do that? Okay. So first we'll do, we'll import a library or a module that's built into CircuitPython called board. And board has a bunch of stuff in it. I could say dir of board. Oops. And it has a list of all the pins that are supported on this board, and also some devices. So there are pins that are around the outside, A0 and so forth. They also have D names. Also on this board, this is a very interesting board. It's not just a microcontroller. It has 2 buttons. It has a speaker. It has a microphone. It has a light sensor. It has infrared transmit and receive. And around the outside, it has 10 RGB LEDs called neopixels, and we'll play with those later. So it's kind of an all-purpose experimenter board, and everything that you're interested in is on that, which is really convenient. So as I said, this little red LED, it happens to be on D13. So in order to turn that light on and off, I can use what's called a digital in-out, which is in the module called digital I/O. So let's import digital I/O. And now let me define a variable called D13. And I can use tab completion. That's how I didn't type it that fast. Okay. So I've created an object that's a digital in/out object. It starts out being an in object, but I'll switch it to output. So I can say D13.switch to something, output. The tab completion is really convenient. In fact, you could also type like just D13.something, and you can see everything that you can do with a particular object. Or for instance, remember I said I had board. If I hit the tab key, it'll show me everything that I can type at that point. So anyway, we had D13. It's a digital in/out. So let's turn it on first. So we'll set its value. First of all, let's see what its value is. It's false. That means it's low. Its voltage is 0. Okay. Let's set its value to true. Okay, what happened? The light came on right here. All right, right next to the blue thing. Let's set it to false. Turned off. Let's set it to true. All right, so you've already made something happen. Okay, you've done physical computing. So why don't we write the classic physical computing program, which is to blink an LED, okay? So to do that, we'll import another module called time, which is a standard module in regular Python. It's not just in CircuitPython. These other modules, board and digital I/O, they're specific to CircuitPython. They're not in regular Python. But now we'll import time, and time has a function called sleep. You can say sleep for 1 second, and you notice there was a little delay right there. So let's write a little loop that turns the LED on and off. So I'll turn it on. Then I'll sleep for a second. I'll turn it off. Sleep for a second. And then when I finish all this, this loop will start to run. While true means run forever, okay? While something is true, true is always true, okay? So now if you look at the what I've got here, you can see, let's see if it's in focus. That's not bad. You can see it blinking. All right, it's blinking once a second. Fantastic. Okay. All right, so that's great. Okay, but let's do some other things too. Another thing that this board has is all these pads around the edge here, all these pin connections, you can use as touch inputs, or many of them you can. Okay, so let's import another module called Touch I/O, which handles all this. And there's a pin A2, and I have old eyes, so I have to see where it is here. Okay, I'll point to it right here. It's labeled A2. I have to use magnifier for that because my eyes aren't as good as they used to be. So let's create a Touch I/O object. And it'll be attached to, it'll be based on the A2 pin on this board, okay? So if I say, am I touching this now? No, okay. All right, now I'll touch it with my finger. Oh, it detected that I'm touching it, okay? And if I took my finger away, now it's false. In fact, I could also get the raw value because it's not just really true or false, it's actually reading an electrical signal. And it says, well, the raw value, which it thinks is it's reading a certain amount of capacitance, is 896. There's a threshold that's 996. It has to be above the threshold in order to register as being touched. So for instance, let me touch it now. I'll go back to the raw value, and you see the raw value is really high, and that's way better, higher than the threshold. So yeah, it says, okay, this is true. And if I wanted to calibrate this, in fact, if I move my hand close, I'm not even touching. Oh, there we go. See, I'm not even touching, but I'm close. It can detect that my hand is really close. Okay, that's great. All right, it's a bit of a nuisance now. We've been doing this. It's a little bit of a nuisance to create all these objects, and you have to remember it's kind of jargon and an idiom to say, oh, create a touch-in object and create it, and so forth. So we created a library called the Adafruit Circuit Playground library that lets you access everything on this particular board really easily. Okay, so let me import that library. And I'm going to import an object that library defines called CP for Circuit Playground. So this is just another form of the import statement. Whoops, I can't do that because it was trying to set up to use D13. So let me just restart CircuitPython. So how do I do that? Well, it's really easy. I just type Control D, and it restarts the whole thing. Oh, it says I'm in safe mode. Let's just forget. Let's do this. That's because it detected a problem. I will restart Mu. This is called the demo effect, when things go wrong. Okay. So anyway, let me just fix one thing here. One thing that I haven't talked about is that how would you get a board to run code automatically? You can do that by making a program called code.py, and when CircuitPython starts, it will, if there's a code.py program on the CircuitPy drive, it will run that program right away. But I don't want it to do that. So let me rename code.py to codex.py. And also let me make sure that that rename has taken effect here. Okay, so now I'm back in the REPL. Let me do that import statement again. Great, okay. So let's look at this CP thing again. Let me get even more space here. So this CP object from the Circuit Playground library has a whole bunch of functionality here. You can see, it's got acceleration. You can find out the temperature. You can you can play tones. You could actually play music files. All these underscore things are internal things you don't have to worry about. You can figure out whether the buttons are pressed. You can get touch inputs and so forth. So let's try some of those. Like, well, what's the temperature? Okay, that's in Celsius, 27 degrees Celsius. And that's just using a temperature sensor that's internal to the chip. Let's see whether the button is pressed, whether button A is pressed. It isn't. Well, let's press it. Now it's pressed, okay? Let's play a tone. You give it the frequency, so 440 is A, and we'll play that for 1 second. Maybe you heard that. It's a pretty small speaker. You could play it for just 0.1 seconds, and it just makes a beep noise. Okay. And that D13 red LED that I was using is called, more conveniently, red LED here. So if I did cp.redLED equals true, it'll turn on, and if I set it to false, it'll turn off. Okay? Now, much more fun are these red, green, blue things around the edge here. So they're all in the pixels. There's a list here called pixels, or an array, and I can just use subscripting in Python style subscripting, and I can give a red, green, blue value as a tuple, which is a Python data structure. So and the red, green, and blue values can vary between 0 and 255. If I make them even slightly too bright, the webcam gets all washed out here. So I'll just try a very small. So I'll set red to 5, green to 0, and blue to 5. And you see that it came on here. Let me make it a little brighter. Okay. Let me move that. There we go. Okay. All right. Well, let's write a program. All right. So far we've just been typing things, but how do you write a program? You don't want to just, this is not the only way you can do it. You're not going to just do this manually all the time. So I talked about creating a file called code.py here. So let's start writing a program here. So I'm going to type in some of the things in this program that I've been typing in the REPL. I'm going to need the time function because I'm going to have something happen over and over again, and I want a delay. I'm going to import that library. That's really convenient. And so let's do something simple. We're going to do kind of a blink program, but with one of the neopixels. So let me just say like color equals that color that I was using. How about a different color? 10, 10, 0. Let's set the 0th pixel to that color. Let's define another color. Let's see. Black, which is everything turned off. Okay. And then I'll sleep for a second. Now I'll turn it off by setting it to black. All right. Let me zoom out a bit so you can see more of the whole program. Move this down. All right. So let's save this program on the board now. Well, that's not where I want to save it. Let's save it on CircuitPy. Where is the CircuitPy drive? It's disappeared. Well, that's not so good. All right, let me unplug it and plug it back in again and see if it recovers. There we go. There we go. So let's save this as code.py. And now I'll just restart things here. Okay, now you can see we're blinking right here. All right, let's change this program. Let's try to blink all of the LEDs, all of the RGB LEDs, all of the neopixels. I think I can do this. I'm not sure. If I can't, that's okay. Nope, I can't do that. Okay, never mind. Oh, I know what's wrong. I know what's wrong. What I have to do is see, I was trying to set one value to 10 values on the other side. So I will. Let's see if I can do this. This may not work. No, never mind. We won't. I won't pursue this because I hadn't tried it in advance. So we'll just go back to 1. Okay, so let's try something else here. Right now I'm just blinking a single color. Let's choose a random color each time we're on the loop instead of always using this 10-10-0 color. So there's a function called random.randRange, which gives you a value between 0 and 50, not including 50, in the way I'm choosing to use it. Okay. So now each time it blinks, it'll be some random color. And if we're interested, we could also print out what the color is. And now you can see the color that it's using. It's displaying down at the bottom here. And what you actually see is a lot of the time it looks just kind of bluish white or something, because when you choose random colors, you tend to get things that are kind of an average of a certain color. So sometimes it's very red, but not usually. Usually it's just kind of some weird random color. All right. So maybe Noe and Pedro, are there questions piled up? I haven't been looking at the chat.
Let's see. We've been answering most of them. They've been kind of like, is there more documentation? So we've been linking to the CircuitPython Essentials link.
Great.
So if folks want more info, they can go to learn.adafruit.com and search for CircuitPython Essentials.
Yeah, been posting links to the newsletter, so you guys can subscribe to all the latest news. It's where all the newest boards and all the newest libraries are added. And you can catch the weekly video that Kattni puts together on all of the newest happenings in CircuitPython on hardware. And I'm also posting links to the recommended hardware, like the reversible USB cable. It seems to be one of the biggest problems when people are first starting out. Make sure that you have a data USB cable, not a charging one.
Yep.
Yeah, that's like 90% of the problem with cables.
Yes.
Yeah.
And like Noah said, linking to the Essentials Guide, which has all of the libraries and a lot of the examples that you were showing, so everybody can go ahead and program along.
Yep. Okay, thank you very much. Okay. All right, so let me go on now from this example. I'm going to unplug this board and plug in another board and talk about CircuitPython libraries a little bit. Let's get this centered here. So I talked about there's the CircuitPython itself, and it has a bunch of built-in stuff that lets you control pins and things like that. But we've also got like on the order of like 250 and going on 300 libraries that support a whole bunch of different pieces of hardware. We sell a lot of breakout boards, motors, sensors, all that kind of stuff. And these libraries support all those things, displays, etc. So on CircuitPython boards that have like more pins, you can connect things up easily to these outside pieces of hardware. Also, really interestingly, you can use these libraries on a Raspberry Pi or some other single board computer that has pins available, because we've written a wrapper library called Blinka, and it isn't CircuitPython, but it emulates stuff like digital I/O and touch I/O and various other things that let you, I'm not sure about touch I/O, but that analog I/O that let you talk to the pins on these boards as if you were running inside CircuitPython. So you're running in regular Python in what's called CPython on, say, a Raspberry Pi, but you're actually using our libraries. so that our libraries can be used not only on the microcontrollers, but on your regular Raspberry Pi or whatever. In fact, there's even an outboard thing called an FT232H that you can connect it to a host computer like a Windows or a Mac machine and talk to it and connect it up to sensors and LEDs and stuff, so that you can even do this kind of stuff from your host computer without having to have a Raspberry Pi or something, though it's easier if you have a single board computer. And I haven't talked anything about Wi-Fi and Bluetooth, but we have support for both of those things. And in particular, we have Bluetooth code that runs on stuff like this Circuit Playground Bluefruit and other Circuit Playground boards. Here's one called a Feather Sense. This little shiny thing here is the microcontroller chip and the radio parts. And this one has other stuff on it, like a humidity sensor and stuff like that, which is really convenient. But we've also made it so that you can use our Bluetooth libraries on host computers that support Bluetooth. Right now, we support Windows and Linux, and we're working on Mac. So you can use our Bluetooth libraries directly from a host computer as long as that host computer supports Bluetooth or has a Bluetooth peripheral on it. So you can use that to talk to other Bluetooth devices or to talk to our boards that can talk Bluetooth. So let's go ahead and talk a little bit about using libraries. So the Circuit Playground board that I showed you, it has a bunch of libraries that are already compiled into the firmware for the temperature sense, for the speaker and the accelerometer that's on it, and the NeoPixel LEDs and so forth. But normally the boards don't come with that, and so you end up loading libraries. You end up needing to fetch those libraries and load them. And I wanted to show you where to get the libraries. So let's go to let's go back to CircuitPython.org, where we were looking at before. And you see there's a link here called Libraries. And if you click on that, you'll see what are called the library bundles. And these are just zip files that are contain all the current libraries. So they've got right now 267 or something like that libraries in them. And there are versions for each version of CircuitPython. Click on the one that you need and download it and unzip it, and you'll find all the libraries. And they're in a pre-compiled form called MPY, which saves space and time compared with the Python files, and also makes it possible to even load libraries that would be too large if you started with the source Python files. So just pick the one that you want, download it, unzip it, and you'll find a bunch of stuff in there. In fact, I could do that right now. So I got one of those zip files, and these are small files. They're not that big. Hello. There we go. Unfortunately, this is really tiny. But you'll see there are many, many, many libraries here. These are all the ones that have, some of the libraries have multiple files, and some of the libraries are just a single file. So I've got like over 260 possibilities here. So you can't copy all of these to your board. You just copy the ones that you need. There's not enough room on CircuitPy for all of these. But I've done that already on another board. I've got this Metro M4 board here. So we can go back to right here. And I've got a sensor connected up here, the SHT31D, which is a humidity sensor. And also I've got a servo motor connected up. And I've got another sensor here, but I hadn't loaded a library for that because I didn't have time to get that set up. So let's try that. So let's go back to this. Let's see if we're connected. Let's see if I can reconnect here. I might need to restart Mu because sometimes it seems to get stuck. There we go. Okay. So now you see we're not running a Circuit Playground Express. We're running an Adafruit Metro M4 Express board. And this board actually, the microcontroller on this board is actually more sophisticated, or it's not more sophisticated. It just has more memory. It's faster, has more RAM and more flash than the Circuit Playground Express. So let's just try a really simple thing here. I'll import the Adafruit SHT31D library, which is for the humidity sensor. And then I'll create an object that is an instance of one of this sensor. Oh, let's see, I've got to do one. I also need to import the board library. What can I type here? I can type SHT31D, and I have to talk to it over an I2C bus. So there's a default one called board.I2C. So now I've got the sensor thing, and what can I do with the sensor? I can say, well, what's the temperature? That's it in Celsius. What's the humidity? It's relative humidity. Okay, 68%. It's kind of muggy here. And there are a bunch of other functions that you can see here, like this sensor actually has a heater so that you can drive off excess moisture and stuff like that. It has a serial number. I've never actually even tried that. All right, great. Okay, and let's try the last thing we'll try here is let's try to make this servo do something. So there's another library that's built in, another module that's built in called Pulse.io. And I also need a library called Adafruit Motor. And let's create a servo object. And it's inside the, I have to import Adafruit motor.servo. So let's create a servo. And I have to give it a pulse width modulation pin. And this is sort of technical, and it's explained in the guides that explain how to use servos with our boards. And I'll do it on the D10 pin on this board. And it's already connected up here. So if that typed, okay, great. So you can watch the arm on the servo. I can just change its angle. Oop, let's go. Go back and forth, and you can see it's spinning back and forth. So you could obviously write a program that moved this back and forth to raise and lower something, or whatever you wanted to do with a servo. So I'm beginning to get run out of time here. We've got about 7 minutes left. So just wondering what else, if there's any other, are there any other questions, Noe and Pedro, that I might?
One that just came up, Brent answered, was how to do the autocomplete, and it's just the tab key.
That's right.
And then a lot of people are just commenting saying that they really like this format, seeing experts, have mistakes, makes them feel more comfortable when they're trying to experiment in their programming journeys. So multiple people saying that they like that. Just
right, you will see, yeah.
Mm-hmm.
Like I got stuck, the program got stuck, the board got in a funny state. All these things make me worried that there are bugs, but it also means that if this happens to you, don't get too upset. It happens to us too. Yeah,
yes,
as you said.
And then shout outs to everybody who's been hanging out in the chat room. We're on Facebook, we're on YouTube, on the Discord. So we have Sean Harold, who is really liking the stream. And see, we have Mark Bozaki. We have, like I said, Brent Rebels hanging out in the chat. We have Scott Shawcroft in here, David, Michael, Gustavo, Renee, David Mitchell, Ricardo Ruiz, Ambarella is hanging out in the chat, Techno Vlogger, Nick. There's so many people in here.
Right. We actually have a question from Scott. So Scott's asking, Dan, what's your favorite part of CircuitPython?
What is my favorite part?
Again,
Tough question.
Yeah.
All of it.
The favorite thing I like about CircuitPython is that I can just type in the REPL and get it to do something. That is really...
That is a really awesome way to kind of...
That is a really right. You do not have to write a program. You do not have to compile a program. You do not have to get this, and you can see immediately what your mistakes are. Unlike using some compiled environment like Arduino, I just tried. You saw, I just tried stuff. I didn't have to write a program. And whenever I say like, oh, is this working or not? The thing that I always do is that I just go into the REPL and try it. I often paste things in.
That's great.
I just wanted to, I think that's the most thrilling part of the whole thing, is to get instant gratification, which is to make something happen, to make something in physical computing happen.
Yeah, I think for us would be just being able to see the code load up on your desktop. There's like so many old projects that were all written on Arduino that we can't access any of that code anymore.
Right. Yeah, that's probably the biggest thing, is that you have your code and libraries with you when you go to a different computer.
Mm-hmm.
That's really useful in lots of different scenarios.
Funny, I can remember when the ideas were still coming up for CircuitPython. I remember we were standing in line at State of Arduino at one of the maker fairs with Scott, and he was explaining how the USB was working. And
our jaws dropped. We were like, "What?"
Yeah. It was so funny because as he was explaining that, as we're waiting in line for the State of Arduino, Massimo walks by. We're like, "Hey, Massimo!"
Hey. It was lots of fun. Okay. Well, do we want to wrap up any other comments?
I'll say one more thing, about Blinka. That also in CircuitPython.org, there's a Blinka link. And these are all the boards that we support under Blinka. All these single board computers, not just Raspberry Pis, but a lot of Raspberry Pis, but many other boards too. And as I remembered, the F232H is a board that you can connect via USB to a host computer and do the same thing. So you don't even need a single board computer with its own pins to do this. You just need this kind of adapter. Other stuff that's in CircuitPython, I think you've given all these links, like the newsletter and how to contribute to CircuitPython.org and where to find help. Oh, let's just go to the forums. Okay, so I think I'm done, and I know what to do better the next time I do this. But that was fun.
I think we could also mention the CircuitPython meetings happen normally every Monday at 2 p.m. Eastern time. It happens in the Discord chat room, so it's a great opportunity for folks to come in and kind of hear and listen in on what's happening with CircuitPython and the community.
Yes. Yeah. And then we have some suggestions if you do get, because streaming does get a little bit addictive, Dan. So for your next one, people are asking if you could do a live stream on writing some CircuitPython drivers, maybe a sensor or a TFT.
Oh, I don't know if I could do that. That might be something for Brian to do, but yeah, I could. That would be fun. Yeah.
Cool. Yeah. Those are great suggestions, folks. Definitely leave them in. Oh, we got one from John Park. John is asking if you could snap your fingers, Dan, and for a new feature in CircuitPython, what would it be?
Huh.
Tough one.
Of course, the internal folks have the tough one.
Yeah, I can't.
What's your favorite part? What would you like
to see? Favorite part, right? Well, I worked on this and I worked on that. I think what I want is that, and we're working on this, is that we want to be able to do things more simultaneously in CircuitPython. Right now, you write a loop and it has to do a bunch of things in sequence, but you'd like to make this happen at the same time and make that happen at the same time, and not have to worry about keeping all those timings in sync. And did you finish something fast enough to be able to do something else? So we're talking about like concurrency and asynchronous events, and we hope to come up with a library for that, and or some built-in support for that soon. And I think that would make it really easy to do a whole bunch of things that are hard right now.
Excellent.
Right,
Well, with that, we are going to end the stream, and Kattni is going to start up the next one.
Yeah, so don't go anywhere. It's live
Hurry up.
show and tell in Spanish. So definitely stick
Yes.
around. We're going to be in the chats helping out Kattni. So we can understand and speak a little bit of Spanish. So we'll try to answer or translate any questions that anybody
Excellent.
might have. But yeah, stick around. There's going to be a whole day of CircuitPython Day. Tons of shows coming up. All the regulars that happen on Wednesday. So stick around. Show and tell is coming up right now.
All right,
Thanks,
folks.
guys.
Bye, everybody.
See ya.
Thanks, Dan.
Thank you.